Right, another past exam question. So this is Core Mathematics C2, January 2007. This is an Edexcel question, and this was question number 6 of that paper. So let's have a look at this question. Find all the solutions in the interval x lying between 2 pi and 0 inclusive of the equation 2 cos squared x plus 1, and that is equal to 5 sine x, given each solution in terms of pi. Now first of all, what I'm going to do is, so let me take my favourite colour blue. First I'm going to work in degrees and then we'll convert into radians. So first of all, this 2 pi, that relates to 360 degrees. So remember, pi radians is 180 degrees. So that would make 2 pi 360. And 0 relates to 0. So again, first I'm going to work in degrees and then we'll convert to radians later using this conversion here. Right, so let me copy down this equation. So we have 2 cos squared x plus 1, and that is equal to 5 sine x. Now the trick to solving an equation like this is we need to write the term with the highest power, which is 2. So write the term with the power 2 in terms of the least power term. So in other words, the term with the power 2 is cos x. So we need to rewrite the cos squared x into a sine squared x term. And in order to do this, we need to use an identity, a trigonometric identity. And the identity concerned would be the fundamental Pythagorean identity, which is cos squared x plus sine squared x, and that is equal to 1. So remember the trick, look at the term with the power 2 or with the degree 2. So the term with the power 2 is the cos, and we need to change this term into the power term, the term with the least power rather, which is sine. So in other words, we need to change the cos squared term to a sine squared term. So that is the reason why we're using this fundamental Pythagorean identity. Now if I rearrange for cos squared, so if I take the sine squared term to the right, we're then going to get cos squared x, that is 1 minus sine squared x. And following this step, let's replace the cos squared x term by 1 minus sine squared x to give us 2 in front, 1 minus sine squared x plus 1, so plus 1, and that is equal to the 5 sine x on the right. Now let's get rid of the brackets. 2 times 1 is 2. 2 times minus sine squared is minus 2 sine squared x plus this one from here, and that is equal to the 5 sine x on the right. Now I want to form a quadratic, so if I take these 3 terms on the left and move them to the right, so by doing that we're going to have this quadratic which should read 2 sine squared x plus the 5 sine x, so plus the 5 sine x. 2 plus 1 is 3, but to the right gives us minus 3, and that is equal to 0. Okay, so this is the quadratic in the form of sine. Now you don't need to do this next step, but I'm going to use a substitution, so I'm going to let t equal sine x. So since I have sine x terms appearing, if I replace the sine x terms by t, we're therefore going to get a quadratic in terms of t. So we're going to have 2 sine x replaced by t, so that gives us 2t squared, plus 5, so plus 5, sine x replaced by t, so 5t, minus 3, and that is equal to 0. Now let's see whether we can factorize this quadratic on the left. So if we were to factorize, so let's see whether this can be done. Let's see whether these two terms will work. So when I multiply, 2t times t is 2t squared, 2t times plus t is plus 6t, minus 1 times t is minus 1t, so the plus 6t minus 1t is plus 5t, and minus 1 times plus 3 is minus 3. So these two terms would be the factors for the left-hand quadratic. Let's go one more stage. Let's work out the t values. So either 2t minus 1 is equal to 0, and if I rearrange for t, so one of our answers should be half, or let me take the second term, so or t plus 3, so t plus 3 is equal to 0, and if I take the plus 3 to the right, t is going to be minus 3. So here are the solutions for t. Now t is sine x, so let's apply these t values to this substitution here. So in this case, don't forget this substitution, t equals sine x. So let's apply these two t values to the substitution. So first things first, so when t is equal to a half, so let's use a half first and apply it. So when I replace t by half, we're going to get sine x is equal to half. Now there's a number of ways to solve a basic trigonometric equation like this, but I tend to use the cast diagram, so that is one such method. So if you're unaware in terms of solving trigonometric equations, I have created videos on my YouTube channel, and I'll provide links to those videos in the description below. But let me talk briefly about the process. Now I see a plus half on the right hand side, and plus half means that our sine, so this equation relates to sine, so our sine is positive. So I'll explain what I mean by that soon. But to work out x, x will be the inverse sine of half, and the inverse sine of half is a standard result. You should get 30 degrees, as sine 30 gives you half. Now going back to the point that I've made earlier, that we have a positive sign on our cast diagram. So if I draw my cast diagram, and on this circle is split up into 4 quadrants. So let me draw my quadrants on this circle. Let me pick up my favourite colour, blue. So it's split up into 4 quadrants, so we label them A, S, T and C. A relates to sine, cos and tan being positive in the first quadrant between 0 degrees and 90 degrees. S relates to only sine is positive between 90 and 180 degrees. So as you can see, we quote the angles in an anti-clockwise order. So starting from here, which is 0, then 90, then 180. T relates to tan, only tan is positive between 180 and 270. And C relates to cos, so only cos is positive between angles of 270 and 1 revolution, which is 360. Okay? So A relates to sine, cos and tan being positive between 0 and 90. In the second quadrant, only sine is positive, cos and tan is negative for angles between 90 and 180. In the third quadrant, only tan is positive, sine and cos is negative for angles between 180 and 270. And in the fourth quadrant, only cos is positive, sine and tan are negative for angles between 270 and 360. Now, going back to this point here, our sine is positive since we have a plus half on the right, and we need to plot 30 degrees on our diagram. So since we're dealing with sine is positive in the all and in the second quadrant, and we need to plot 30, and we measure the angle from the horizontal line. So from the horizontal in the first quadrant, so 30 degrees is roughly this line, and in the second quadrant again from the horizontal, so from the horizontal 30 degrees, roughly just a rough representation of 30 represented by this line. Now we measure positive angles from the 0 degree, so we call this the initial line. So we measure the solutions from the initial line, and positive answers are measured in the anti-clockwise direction. Negative answers are measured in the clockwise direction. Now going back to our question, we're looking for positive x between 0, and since we're working in degrees, between 0 degrees and 360 degrees. Okay, so going back to this particular point here, so let's measure positive solutions. So the first positive x, which I'm naming x1, so if I take a red colour pen, so from the initial line, the 0 degree line, in the anti-clockwise direction until you hit the first line, the first answer, as you can see, is 30 degrees. And the next value, so bearing in mind, if we go back to the question, our range extends to 360, not including 360, but extends to values below 360. So we can calculate another one, and another one would be, if I take let me take a green pen, another one would be from the initial line, the 0 degree line, right round until you hit the second line. Okay, so that angle will be 180, the angle in a straight line, so it'll be 180 minus this acute angle of 30 degrees. So that would be, so 180 minus 30, 150 degrees. Now, we can't calculate another one. If you were to calculate another one, it would be from the initial line 0, right round, which is 1 revolution, plus 30. So 360 plus 30 is 390, and this goes beyond our range. So all in all, we have 2 solutions. Now bearing in mind these solutions are in degrees, but remember the conversion, pi radians is 180 degrees. So let me pick up my red pen just as a reminder. So pi radians is 180 degrees. Okay, so that means that 1 of a degree is pi over 180 radians. So I wrote down the conversion in red. I found it for 1 degree because we can multiply both of these by a factor of pi over 180. So if I multiply these by a factor of pi over 180, so let's have a look. So if I pick up my blue pen, so I can make a cancellation of these 2 zeros, but also 3 goes into 18, so 3 goes into 18 6 times. So one of my answers will be pi over 6 radians. And I can make a cancellation here also, cancelling the zeros. So in this case, so we can cancel by 3. 3 goes into 15 5 times, 3 goes into 18 6 times. So let me write that as 5 pi over 6 radians. So now for t equals minus 3, which is the second t value here, so let's have a look at what's going to happen for this value of t. So let me pick up my pen. So when t is equal to minus 3, if I put that into the substitution, so remember our substitution is t equals sine x, so if I replace t by minus 3, we're going to have sine x, and that is equal to minus 3. Now, looking at this equation, it's not going to work as sine x has a range, and the range of sine, it lies between 1 and minus 1. So sine x lies between 1 and minus 1. So this equation that we have, sine x equals minus 3, doesn't work in this instance. So I'm going to mark it with a cross next to it, meaning that it's meaningless. So all in all, we have two solutions for x. The first solution being pi over 6, the next solution being 5 pi over 6. So that covers this question, question number 6 from the paper C2 January 2007. So I hope you enjoyed this video, and if you did enjoy the video, be sure to subscribe, be sure to like the video, and I hope to see you again. Thank you.